Okay, we're going to start these notes with balancing equations. And we're using the theory of the conservation of mass, which states that matter can never be created or destroyed, which means that all of the matter that we have on the earth is already here, and we can't make any of it out of something, but we also can't get rid of any of it. We can change the way that it is used. We can compound coal into making diamonds over millions of years. We can burn something and change it into smoke and soot, but the matter, the actual atoms that make up that soot and that fire don't change. They just get rearranged. And don't forget that a theory in science, remember, is more than just I have a theory about why that guy likes me. That's just a thought or some sort of an idea that you might have. A theory in science means that scientists have done research, that there's been experiments, and that the entire scientific community feel that this theory best explains the observations that we've made. Okay, so if we start out with an equation like this, 2 hydrogen atoms plus 2 oxygen atoms make 1 water molecule or water compound. I want you to remember back to ChemThink how these symbols represented 1 atom of different elements. So this is oxygen in the blue, and this is hydrogen in the red. So what this H2 is showing you is that there are 2 atoms of hydrogen that are bonded to each other to make a molecule of hydrogen. And what this subscript here, this 2, is showing you for the oxygen is that 2 oxygen atoms are bound together and make an oxygen molecule. And then when these 2 things get mixed together, they make water. And here's what a water molecule looks like. Now, because of the law of conservation of mass, everything on this side of the equation has to equal what is on this side of the equation, okay? And we have a problem because we have 2 hydrogen atoms here and 2 hydrogen atoms here. We have 2 oxygen atoms over here and only 1 on this side. So you might think, well, could I just add an oxygen molecule? So maybe I could put a 2 over here. Well, the problem is that if you put a 2 there, this is the molecule that you're actually talking about. 2 oxygen atoms and 2 hydrogen atoms. And this molecule is not water. Okay? So the first rule that you need to know about balancing equations is these little numbers, which are called subscripts, you can never change them. Okay? They are in the equation to show you how the atoms are bound to each other. So you can't ever change those. So let's go back to how we had it before. And what can we do to make this equation balance? Well, we can use a number in front of the compound. I'm going to put a 2 here. And what that means is I've got 2 now molecules. See, I've still got water over here, but now I have 2 molecules of water, or this is a compound of water and this is a compound of water. So now our oxygens are balanced. So I've got 2 on the left side and 2 on the right side. The problem is that now I have 1, 2, 3, 4 hydrogens. And if you look up here, this 2 means that I have 2 of all of this, everything that comes after the 2. So now I need 2 more hydrogens on this side. So I can put a 2 in front of the hydrogen and make myself 2 hydrogen molecules. Now I've got 1, 2, 3, 4 hydrogen atoms here. 1, 2, 3, 4 hydrogen atoms on this side. 1, 2 oxygen atoms here, and 1, 2 oxygen atoms on this side. So this is a balanced equation for hydrogen plus oxygen making water. Now we're going to put some terms on, add some terms in here. This side of the equation is called the reactant side. And I think that's easy to remember because they are the things that go through the reaction. So the reactants are part of the reaction. And then the right side is the product. And a product is something that you make. So the reactants go together in a reaction to make a product. And then this little arrow is called a yield sign. And it's very similar to the equal sign in math, but what it means is that I'm going to start with these things and I'm going to make this. I can't take this and go back this way. Okay, so it gives you the direction of the chemical reaction. I'm going to add hydrogen and oxygen together, and that will always make water. Now, when you get to high school, there are some reactions that can go in both directions. So sometime for a while, the reaction will go this way, and then there'll be another arrow pointing back towards the reactants. But for our purposes, all of the reactions we're going to be looking at will all go to the right. Okay, this number that we put in front is called a coefficient, and that multiplies the number of molecules or elements that are to the right of it. So here we had 2 H2O molecules, here we had 2 hydrogen molecules. So that's called a coefficient. All right, since atoms may be created or destroyed in a chemical reaction, all that can happen is, since no atoms may be created or destroyed in a chemical reaction, all that can happen is rearrangement. I like this diagram because it's showing how the hydrogens and the oxygens are bound to each other. For middle school, you're not going to need to know about single or double bonds, but when you get to high school, you will. So these 2 hydrogen atoms are made into a molecule by a single bond. There's the single bond. The oxygen atoms are bound together by a double bond because there's 2 lines here. So after the reaction, all of these bonds are broken and there's reattachment. So now there's a single bond between this hydrogen and oxygen and a single bond between this hydrogen and oxygen. Single bond between this hydrogen and oxygen, single bond between this hydrogen and oxygen. So this diagram is a real easy way to see that we didn't gain or lose any atoms. We just rearranged how they were connected to each other. Here's another illustration that's very similar to what I showed you before, but now the symbols are inside of the atom and molecule representations. So this is H2 plus H2 plus O2 yields 2 molecules of water. Okay, you're going to fill in some notes. Atoms are not blank or blank during a chemical reaction, and that should be created or destroyed. Scientists know that there must be the blank number of atoms on each blank of the blank. Scientists know that there must be the same number of atoms on each side of the equation. Next, to balance the chemical equation, you must add a coefficient to the different parts of the equation. And you can pause and go back on these parts to write them down. All right, now I'm going to give you a couple of examples for magnesium. This is a magnesium atom plus an oxygen molecule yields magnesium-oxygen compound. Now these lines are here just to show you that this is where you might put a coefficient. So first I'm going to look and see that I've got 1 magnesium on the left and 1 on the right. So those are balanced. But I have 2 oxygens here on the left, so I need 2 over here. Remember, you cannot put a little number down here. You have to use a coefficient. So if I put a 2 in front, now I've got 2 oxygens, and the oxygens are balanced. But on the right, I also now have 2 magnesiums, so I need to add a 2 to the other side. So this is now a balanced equation. Again, pause and think about it if you need some time. Here's another example. On the left, I have a calcium atom. On the right, I have a calcium atom. On the left, I have 2 oxygen atoms. On the right, I only have 1. So I'm going to add a coefficient of 2 in front of this molecule. Now I have 2 calciums and 2 oxygens. So I need to add another coefficient to the left. So that gives me 2 calciums on the left, 2 oxygens on the left, 2 calciums on the right, 2 oxygens on the right. Next is H2O2, which is hydrogen peroxide, breaking down into water and oxygen. And you can see this happen if you dump hydrogen peroxide out of the bottle. So on the left, I have 2 hydrogens. On the right, I have 2 hydrogens. On the left, I have 2 oxygens, and I've got 2 over here, but I have to add this one, so I have 3 on the right. Usually, if you have an odd number, it's best to start with even numbers. So I'm going to change this one from the beginning here. Now I have 2 oxygens here because I have 2 water molecules and 2 over here. So that's 4 total on this side. So I need to add a coefficient over here to make 4 oxygens on this side. So I've got 2 times 2 is 4 oxygens. Now let's look at the hydrogens. 2 times 2 is 4 hydrogens. 2 times 2 is 4 hydrogens. So those are good. Okay, these next equations, I've got 2 nitrogens on the left and 1 on the right. So I'm going to put a 2 in front of that. So now those are balanced. Now I've got 2 times 3 is 6 hydrogens on the left. If I multiply this hydrogen molecule times 3, it would be 2 times 3 is 6 on the left and 6 on the right. So this is balanced. The next one is copper. I have 2 coppers on this side. I need 2 on this side. But I'm looking and I've got 2 oxygens here and I've only got 1 oxygen here. So I'm going to add a 2 here at the front. So now I've got 2 oxygens on the left, 2 oxygens on the right. I just changed this copper to be 4 on the left, so I'm going to change it to 4 on the right. Carbons are still balanced. 2 oxygens on the left, 2 oxygens on the right, so that's balanced. Last one, 1 sodium on the left, 2 on the right, so I'm going to fix that. Now I'm going to look at the oxygens. I have 2 here plus these 4, so that's 6 on the left. I have 4 plus 1 is only 5 on the right. So I'm going to add a coefficient of 2. Now I have 4 oxygens here and 2 oxygens here. So that's 6 on the right and 6 on the left. And let's see what happened to the hydrogens. I have 2 hydrogens on this side plus these 2 make 4. And 2 times 2 is 4 hydrogens on this side. If you have any questions, please come and see me, and I can help you work through these.